Okay, great. What's up, y'all? It's CSSS 508. This is our week 5 lab. Do we have any questions before I get started? Walk through this homework. Cool. So I've already went ahead and gone to the course website and copy pasted the template. And when we knit, let's see what we get. Let's see. We get some instructions here. Questions for you to answer are as quoted blocks of text. Put your code used to address these questions and interpretations below each block. Make sure your answers are not in block quotes like these. Load all libraries you want to use in the setup chunk. When you discover you want to use a library later, add it to the setup chunk at the top. You'll turn in part 1 for the coming week and part 2 for the following week. You'll upload the entire template each time with whatever progress you made. Part 1, getting the data in. Download the data from this giant link, which I realized I think was incorrect before. It goes to the same data, but it was from Chuck's class, who used to teach this class before I did. It's a plain text file of data, about 60 megabits in size. Values are separated with commas. You can see this by opening it with a good text editor, things like Atom or Sublime, but not Notepad. Don't open it in Notepad. Save it in the same folder as this template and read the file into R. You want to use the cache equals true chunk option for this and potentially other trunks. Cache equals true will allow R to read the file only once to save time. Okay. So let's see. What have we learned so far in this class? Ooh. Library dplyr will probably need dplyr. I don't recall any graphing so far, so we probably want tidier. And let's see, reader. I think the last one was forecast. Talks a little bit about forecasts. And if we need another one, we'll come back to this setup chunk. Note this already has been named setup. We probably also want to add a message equals false, so that it doesn't say, oh, this was built in such and such time for R whenever. So we want to get the data in. Since I'm on a school computer while I'm recording this, and it's been really finicky about downloading things, I am going to cheat a little bit on the instructions here. Please follow the instructions here when you do this. I'll in fact show you how to do that. You're going to go to the course website here. Here's the homework 5 data. It says don't open a browser. You can just save link as and save this to a place. Note it said file or failed. Again, I don't know why school computers are upset about me doing school things on the computer. But I'm going to use a little workaround. Oops. So here we go. We'll name our data, I don't know, KC raw for King County. And we're going to use from the reader package, the read_CSV. And now I can just put that link in quotes, and it will take the data straight from the internet and bring it to my R instance. Also note, cache equals true is already in this chunk that's already named import data. So it's not going to go to the internet and download the thing every time we knit the document. Okay, what's our first question? In the inspecting the data section, it says, Use glimpse to look at the data. Describe the data in their current state. How many rows are there? What variables are there? What kinds of values do they take? Don't list them all if there are many. Are the columns sensible? Let's find out. So we have this KC raw data, and we can type that into the glimpse function. You don't have to do it this way. Normally, this is just the first thing that comes to my mind, is to type things like that. Let's see, what were some of our questions? How many rows are there? There are a little over 640,000 rows. We have 9 columns. These columns are things like precinct, race, some acronyms, I'm not quite sure what they mean, counter group, party, counter type, sum of count. We have 3 variables here in the middle that are numbers of some kind. And then one at the end, sum of count, that's probably important to voting. That is also some numbers. Everything else is a character, and nothing appears to be like full of NAs. I feel like these column types are pretty sensible so far. Question? Without getting all of the backslashes from the file location. Yes, if your markdown is saved in the same place as the text document, then you can just call whatever the regular title of the thing is. So an example from, I don't know, the time I took MLE. So there is my R package here, or my R script, and then here is EVP M1, M2. In my R script, I could just call this without having to know the like address that takes me all the way there, because it's in the same folder as my markdown.
Inline code some of the like text response to describe those?
That would be great. You don't have to. Probably. Okay, are we cool on this first chunk? Question? Sure. So these are the libraries. dplyr for pipes and things. Tidier for like pivoting and moving things around. Reader so that we can import the data in. And forcats in the case that we have some categories that we have to deal with later. Of course.
What another page where we can see what each of these variables is, like a description of variables?
No. That was part of the puzzle of the homework. Okay, are we cool with glimpse? Where we're at with that? Okay. In addition to looking generally, look at each variable individually, except consider LEG, CC, and CG at the same time. I will tell you now that these 3 aren't likely to be useful to you, but maybe you can guess what they are. Remember, these are real administrative data. So they may be really strangely structured, and some variables are indecipherable. In real world data work, you often have to get by with intuition and poking around online with regard to the nature of your data. Here's a useful way to look at 10 unique values of individual columns given some data in a variable of interest. So you could say data and then distinct variable and then head 10. Another thing you may want to do is get a frequency or the count of distinct values using the count function. So we know that our precinct variable is already character and appears to be just local Seattle precincts. And we only see a dare here in the glimpse, but maybe we could get the count of our precincts. And we could just look at the first 10 rows of that. And so what's going to happen is it's going to group by all of our unique values in the precinct column and then count how many rows have each of those unique values. What we'll see here, if we look at the first 10 rows, which are arranged in alphabetical order, Adair has about 237 rows. Aldara has 257. Alder Springs has 237. These seem pretty reasonable to me at this stage. Seems to just be, I don't know, the name of a neighborhood or some sort of ID number for a place that maybe doesn't have like a really strong neighborhood name. Does anybody here say Uptown for Queen Anne? Sorry. Yeah, I'm not doing that. You might also want to just do the same thing, but maybe look at the last 10. Seems to be about the same thing at the bottom of our counted data set. We did have a question earlier about whether or not you might want to have maybe some inline R codes describing some of this data. Maybe you would want to say precinct count, and you could say AC raw distinct precincts and row. And so this would just tell you how many distinct precincts there are. And then down here you could say number of distinct precincts in the data is something like that. You'll see over here in the environment, it says there's an integer of 2,517. That's what the L is telling us, that it's an integer. So we're cool there on precinct. Feeling pretty comfy about where the data is for the precinct column at the least. Let's see, we have race. What could this tell us here? We could do the same thing, count by race to see the top 10 or the first 10. And let's see, what do we got here? Race appears to be different things on the ballot. Advisory vote 14, perhaps a proposition in Bellevue. I'm not sure where Duval is, but they had something to vote on. But that seems pretty straightforward, right? And that the place that I don't know where it is only has 42 rows, whereas Bellevue has 1,000, and a place that I assume like Attorney General for Seattle has 17,000 rows dealing with it. That tracks. As described in the instructions, it says you should take the LEG, CC, and CG all at the same time. So let's see those. And if you'll recall, they were all double. So maybe we should look into that. We'll select LEG, CC, and CG. So this is going to get rid of all the columns that aren't these ones that we specified here. And it said it was numbers. So let's just throw it into a summary. Let's see. LEG seems to have 224 missing. CC has 224 missing. I would guess that those are the same missings. CG doesn't have anything missing. All of our like actual values, so like our min and our max, are whole numbers, and only our means are not, which suggests to me that these are probably categorical. These are like something telling me that you're not going to have any decimal values.
For you think that also for LED because the max is 48.
I think so. I mean, I do know, but I'm the the yes, because 48, if it was like 48.5, I'd start to question that all these other numbers were so 0.00. But since it's not, I'm pretty comfy with thinking that it's probably a category.
Aren't there lots of things that it can just be whole numbers? Like if you're only asking something to record like their age in a whole number.
Certainly. But given the nature of the data set, like I'm thinking that they've broken up the something into numbers that are easy to deal with, that they don't have names for. Maybe next we can look into the missingness that we have. We could say Casey raw, and then filter is that NA leg. I know we're so used to just getting rid of all of our NAs, but this is to keep our NAs. And let's just see what the first 10 rows of that looks like. And we have a precinct that's called the elections office. People still vote there, it seems like. I don't know, it doesn't sound like a real precinct to me, looking at that. I think we could think about dropping those rows. If this were not for a class assignment, I would think very seriously about dropping those rows, but they're probably fine for this. So this says that there's a precinct called the elections office. And I'm skeptical that there's a neighborhood in Seattle called elections office. And so I think that this might be some sort of nuance in our data set that makes sense in the Excel spreadsheet that it comes from, but maybe not to us as an R user trying to manipulate the data for other purposes. Okay. We have counter group, which is another one of the character data that we had, so we could just count it and see where we're at. And wouldn't you know, it's a column with all of the same values or the word total. That's it. And that is the life of dealing with administrative data. It happens all the time. That's good to know. Let's move on. Let's see, we have party. I mean, I feel like we all have a guess about what party's going to say. Let's say we count party and then we'll also arrange it. We should probably arrange it by n. And the reason that we can arrange by n in this backticks here is because when we run party, it produces a new column called n. And so what I'm saying here is arrange in descending order this column n that count produces. And so what we see here are what might be political parties. NP in a King County election probably means nonpartisan. When you're, or no party, I mean, when you're voting for like the paper boy or something, there's not really a need for a party. And then Dem and Rep are probably pretty clear, pretty large amount of libertarians, I'd say, for a major city, but maybe not. Maybe Democratic Party National, DPN, maybe Green Party. I don't know. But I think we have some like good material to work with there. A couple of ideas.
Does it mean anything that all of the three-letter acronyms are the exact, have the exact end?
Probably, right?
Oh, I didn't know this.
But this does say that there's probably some race somewhere that, you know, 2,517 some odd rows dealt with, where there was a lot of parties for one race, maybe. What that race would be, I don't know, but yeah, I don't know. Let's see, counter type. And what is this information? Some of these look like candidates for things. Some of these look like information for some sort of proposition. It's got to be hard going around signing your name B Knowles. Okay. Maybe we should also see the bottom end of this list. Yeah. Here's something interesting. The times blank voted, times counted, times overvoted. So it seems like write-in, it seems like there's information in here that's not just the candidates, but in fact, like information about the total amount of counts of some kind. That's good to know. Need detail for the count of counter type. I clicked through here to the bottom to see more of the rows. Perhaps you only saw these first 10. Yes, so in our data, we have a row where it says like the precinct and the race and the party, and then the counter type will say Sharon Santos. And each time there's a row like that, it counts it all up for Sharon Santos, and there's 174 rows of that kind in our data. It certainly suggests, given that we have like times blank voted, times counted, times overvoted, that this column is too long, and that we want to be able to separate these into their own columns of some kind with their values from another column. I can't remember the exact verbiage I said in the lecture last week, but it was something like, if your column tells you more than one type of information, you probably have too long a column. Okay, let's look at sum of count. Select sum of count. I think this was our only other remaining numeric or integer data. So let's try a summary again. Now, similarly, this is telling me that there's nothing here on the other end of the decimal. So I'm starting to wonder a little bit, not unlike the other ones that I didn't know what they were. I mean, sum of count is a little bit more straightforward, given that we're looking at elections data. Perhaps we should look at the sum of count next to counter type, so that we can maybe disentangle the things like who Sharon was and what was times voted next to our sum of counts figures. So one way we could do that would be we select the precinct and race, because we have a theory that like a row will say precinct and race, and then this is the person that was the vote for, and this is the amount of counts. So we'll take the counter type and the sum of counts. And let's just say like head 10. Okay, let's spell precinct. And what do we see here for Adair in the advisory vote 14? the sum of count for times counted is 485. I'm like ballparking in my head. 51 plus 251 is like 300. And 300 plus 183 is like basically 485. So I feel like I'm starting to think that like times counted might be of like vital importance. Whereas these other things just tell me information relative to times counted. Or perhaps relative to registered voters. And this seems to make me think also that the number isn't just some category of some place. Great. Oh, one thing I forgot to mention, now that we know that the LEG and CC and CG are not that important to us, we could actually just go back up here to the top to where we loaded the data and use the call types argument. And we could say CC. And this would coerce our data into being character for the first 8 rows that logged in or that get imported in left or right, and the integer just for the last one. Because sum of counts are only true integer. You don't have to do that though. If I was going to be using this data for another purpose, I would do that. Did I have not enough C's? Yes, because it's just one for each of our columns, except for our last one that's the sum of count, which is integer. So we have 8 character data columns and 1 integer data column. But I'll load the data again to show you what I'm talking about. So now if we run glimpse, then our leg and CC and CG are all in quotes. Our sum of count data produced NAs for some reason. It was double before?
Yeah.
Trying to remember what the thing is. Maybe just a D? I think capital D is date. Yeah, lowercase d for double. Thank you. Okay, so let's get to our quantities of interest. We'll focus on only 3 major executive races in Washington in 2016: president and vice president, governor and lieutenant governor. With these races, we are interested in, first, the turnout rates. For each of these races in each precinct, we will measure turnout as times votes were counted, including for a candidate, blank, write-in, or overvote, divided by the number of registered voters. Differences, or number 2, we're interested in differences between precincts in Seattle and precincts elsewhere in King County. Again, these data are not documented, so you will have to figure out how to do this. And number 3, precinct level support for the Democratic candidates in King County in 2012. That's a typo. For each contest, we will measure support as the percentage of votes in a precinct for the Democratic candidates out of all votes for candidates or write-ins. Do not include blank votes or overvotes, where the voter indicated multiple choices, in the overall vote count for the denominator. You'll perform most of the data management for number 1 and number 2 in part 1. Part 2 will contain most of the work for number 3 and also covers visualizing results. The goal is to accomplish over parts 1 and 2 will be to get the data to one row per precinct with the following 7 columns. A precinct identifier, an indicator for whether the precinct is in Seattle or not, precinct size in terms of registered voters, the turnout rate, and the percentage of Democratic support for president, support for governor, and support for the lieutenant governor. The section below describes steps you may want to do to get your data organized and provide some hints and suggestions for methods, in particular using dplyr and tidyr. So filtering down the data. For what we want to do, there are a lot of rows that are not useful. We only want ones pertaining to races for president, governor, and lieutenant governor. So let's trim everything down. You'll want to see how these things show up in the data. The easiest way may be to, 1, display every unique value of race and find which ones match our races of interest. Then 2, filter the data to those races. Okay, so our first suggestion was display every unique value of race and find which one matches our races of interest. So we could say Casey raw and then select the race column and then get the distinct values of race and then arrange. When we look at this, we'll see that we have 98 rows of some races. These are not president or governor. There's governor. Hello. There's also lieutenant governor around here somewhere. Right here. And did I pass president? Look. There's proposed. US president and vice president. Great.
So this would be like a good, like I have data where people can self-enter like their country. And so people say like, I'm Argentinian or I'm from Argentina. So this would be where you find like all the unique ways to say Argentina.
Yes.
Yeah.
Of course. But we also want to know where these are in the data, so it's easier to, I don't know, maybe not easier, but the fastest way I can think of to subset would be to get the races, take all of this information and assign it to its own object. And then we could print them out as a character vector. Wait, that was incorrect, like this. So now we have this great big list, but now it also tells us what the index number is for each of the things. So we had our governor, which is 26. Our lieutenant governor is 79. And US president and vice president is 97. And now we could say, our relevant races are our races column there. And we'll subset to just the ones that we saw. So 26, 79, 97. And we'll see that our relevant races thing just tells us those three characters that we're interested in, those three strings: governor, lieutenant governor, US president, and vice president. And then we could make KC rel races, which is going to be our KC raw data that's filtered to just be the races that are percent and percent relevant races.
What's the other way to do the percent? Is it like, I forget what that.
This is a shorthand for instead doing something like equals equals US president and vice president, or no.
Oh,
Yes.
so it searches for like or the value.
It's comparing the values in that vector with the values in your column that you already have. And the percent and percent lets you do multiple matches. Whereas equals equals is only for one match.
Got it.
We should probably also see what the first few rows are looking like. So they're all the governor races, it looks like. And the bottom looks like it's got all the president. We could even, instead of doing that, throw it in a glimpse. And we're still feeling pretty comfy that it's the governor and that it's got stuff like Jay Inslee as the counter type. So we're cool with how we subset the data just to get to our relevant races. I personally like to subset things this way because I would definitely misspell lieutenant. Yes. Run what again? The whole chunk?
Yeah.
Okay. Of course. Okay. We're cool to move on. In our Seattle precinct section, it says, we want to determine which precincts are in Seattle and which are not. You should look at the values of the precinct variable and see if you can figure out what uniquely identifies Seattle precincts. Hint, all Seattle tracks have the same naming scheme, but some non-Seattle tracks are similar, so be careful. You'll then want to create a binary variable that identifies Seattle tracks, for instance, with values Seattle and not Seattle. One approach you can use is with the stringer function string sub or base R's substring to grab a number of characters, a substring from text, say to test if they are equal to something. If you use this with if else, inside of a mutate function, you can make a new variable based on whether the substring of precincts equals a value.
The double colons, that's like pulling something from a library that you don't necessarily want to load.
Yes. So let's take our king or KC races, and then we'll select precincts because we're interested in Seattle and not Seattle precincts. And we'll get our distinct ones. And then we'll arrange. Not unlike we did earlier. But now we're like, goodness gracious, we got 2,517 of these bad boys. Maybe we want to arrange in descending order and check that way. This is what I'm talking about. SEA, yep. Yes. So I could get them all in alphabetical order. Even though I think the data comes to us in alphabetical order, that's not something I like to trifle with. If you're not a fan of clicking around through those kinds of things, you could make a new column called precincts, or a new data frame called precincts, and scroll through this way. If you're more of a scroller. But it seems pretty clear to me that SEA denotes Seattle. So what we can do is say, KC flag, because we're going to flag which ones are the Seattle precincts. We'll say our King Rel races data, and then we'll mutate because we're interested in making a new column that tells us whether or not something's in Seattle or not. And let's call it E flag. And it's going to be equal to if else. And let's not have to load a new package. Let's say substr precinct. And if you recall from the slides, I don't know if we described this exactly a couple weeks back, but the arguments that substring takes are places in the character string. So you can say start equals 1 and stop equals 3, and it will look at the first 3 characters in a character string, and it will cut to just those. And we can say substring precinct, just the first 3 characters in it, is equals to SEA. Because recall, we're over here, and we felt pretty comfortable that Seattle was all of our SEAs, especially for how much of the data it takes up for our King County. So we're just going to look at those first 3. And after our logical expression in the if else, we want to provide what each of the answers will be. So if the first 3 characters in our character string for precinct is the same thing as SEA, return Seattle. And if it's not equal to that, return not Seattle. King rel races. I see. My bad, I misspelled that. And now we could, let's say, take our KC flag data and select just the precinct and C flag. Adair's not in Seattle. I'm feeling good about that. Actually, let's call this KC Seattle just to look at it. So we can look at it in the viewer. So we're feeling pretty good that Alder Springs is not Seattle and that Alpine is not Seattle. Fed, probably Federal Way, not Seattle. Whereas all of our SEAs, they are Seattle. I did want to note one very unfortunate thing about administrative data. If I can scroll there. Y'all can see it. I'm not one of these scrollers. Oh, Lord. Spider Lake sounds cool. Whoa. What's SHL? Shoreline. I see. Oof. Yeah. Sean is a place I've never been. And Seaview is a place I've never heard of. But our current parameterization of how to determine if something's in Seattle is based on these kinds of nuances. So it's always good to like double check and triple check that this is going to be Seattle and South, which I don't know. Does South have good pizza? Like, I don't know anything about South. So to combat this, of course, we could just say, look at the first 4 characters in our string and add a space over here. And so what that would do is keep only the ones that are like SEA space a bunch of numbers of some kind of identifier.
If there wasn't a space and it just went immediately into like the code of the precinct, could you say like starts with SEA and then has a number?
Yes, we could. The way that we're going to do that is going to be discussed in, I think, week 9 of this course. Okay. So we'll run that, and that'll be about right. I feel like for all of the folks at home, I should show the example of how you could do this with the other stringer function. So let's say we can make KC flag alt, and we'll have the same setup of like feeding it the KC rel races and then making a new column, also called C flag, that is equal to if else, and we're going to call from our stringer package string sub, and actually we don't need string sub. It's probably better to use string detect, which we will also be talking about more in week 9, I think. And we'll give it the precinct column, and then we'll give it the regex. This little up here is saying, look at the beginning of the string. And we'll say the same thing, not Seattle and Seattle. And we can make that. And then we could say some AC flag not equal to AC flag alt C flag. And they're all the same answers. So that's just for folks at home. Congrats. That's the way you could do this.
Sorry if I missed it. Change stock from 3 to 4.
The reason for doing that is that we had some answers like Sean and Seaview, and we wanted to get rid of those. And we knew that the other Seattle ones were like SEA space a bunch of numbers. Okay, great. So we want to calculate turnout rates as total votes, including normal votes, blank votes, overvotes, write-ins for the presidential race divided by the registered voters. Here we have some cool maths that only shows up in the NIT. Halted because of line 15. It's just one letter. Why is it like this? Okay. I just want to talk about how cool it is that you can put little tech math and stuff. I find this so useful for homework assignments, but also just for regular publishing papers where you need to describe, you know, some matrix algebra thing that you had to do with your model. So keep that in mind. That's the thing that you can do in R Markdown. Here we are. So you'll want to look at counter type and sum of count at the same time within each precinct and race. Examine how the sum of count values for counter type examine how the sum of count values for counter type value times counted relate to all other counter type values. I talked about this briefly before because I'm really bad about spilling the beans. So let's see. We were interested in times counted. We knew that it was the sum of all of the other types. So let's look at it again. Select. We're interested in, let's say, precinct, race, counter type, and sum of counts, I think were the ones we use. Right. And so if we look at this governor race in Adair, then let's see, we have 224 votes for Bill Bryant, 256 for Jay Inslee, 519 total registered voters, 4 blank votes, 0 overvotes, 1 write-in, and 485 times counted. So we feel comfortable that times counted is just the sum of all of the things that are not the registered voters count. So one thing we could do is cut all of our rows down to not include registered voters and times counted. And then our sum of by precinct and race would give us our correct numbers. Are we following?
You ever want to check that with check for him?
Yes. I would, in a non-homework setting, this will check for you during part 2. So we're going to filter that our counter type is not equal to registered voters. One and here, and counter type is not equal to times counted. And then I wanted to group by our precinct and the race, and then summarize votes added up, we'll call it. Votes added up equals the sum of our sum of count column. So like before, in Adair, we had the governor race, and it's equal to 485, like our times counted row told us it would be. Also, we're getting this message summarizes group of, okay, that's fine. So let's call this something times counted manual. We manually counted all of the votes. We could also make a times counted comparison, which is going to be, we still want to select here a precinct, race, and counter type. Count. Then we want to filter our counter type to equals times counted, because we have the suspicion that, you know, maybe this sum of the sum of count column before doesn't give us the same thing as the times counted. So please look at those. These appear to be the same thing for each of our votes added up columns. Here we don't have to make a votes added up column because we didn't add anything. It just is the sum of count column still. But the numbers appear to be the same. Sorry, did I get a hand back there?
Trying to see what you look
Okay. There I did just a eyeball inspection. I guess we should do a numbers inspection. Trying to think about what's the best way to do that. Let's rename times counted value equals our sum of count column, right? So we're just saying that this is what the value of that is. This is what we're just saying that now that our sum of count, when it's filtered just to times counted, is going to be called times counted value. And then we could left join to this data our times counted manual by precinct and race. And then we would want to make a new column with that joined data. That's going to be called differences in count. And that's going to be our times counted value minus our votes added up column from the other data set. And then we could say, give me a summary of the times counted comparison differences in count. And it's all zeros because all of the differences in count across all of the rows by precinct and data are the same. So that's one way you could check without having to just eyeball it. Okay, are we cool with that? Or are we still looking? Great. I don't know. If I didn't put them in quotes. Yeah, I'm not sure. Let's try. I see. So it suspects that this word precinct is a vector or something lying around in your environment, rather than a column that's already in both of the data sets that you're trying to join with. Question. Scroll up just a bit. Okay. I'm sorry? Yes. That's correct.
I didn't know to add. Oh, we're adding. Yeah, my summary tells me it's times kind of comparison. Object times kind of comparison.
So up here. This object was not created.
Oh, it's not usually.
I see.
Before mine says you might want to talk about for the first part of the camp. Summarize the group by precinct. We wanted it.
Yes, that's just a message for a very specific case. You would just want to say message equals false up here for that kind of thing. Whenever I had this using the dot groups argument, didn't go away with message equals false. Maybe it only goes away in the net. I don't seem to recall. But are we cool with this? Okay. This isn't the, you didn't have to do this whole section down here, right? Like that's why I said we could eyeball it and tell pretty comfortably. So if this part is tripping you up, that's okay.
No, I have the next arrow.
Okay, we'll handle that right after this. As this is the last little chunk of stuff we want to know. So what we're interested in is the turnout rates for the presidential race. So let's take our KC flag data. And then we only want the presidential race. So we'll filter race is going to be equals to, let's just use our relevant races vector. I don't quite remember what's in that one. So I'm going to say this. It appears to be our third object. So I'm just going to subset to our third element there. And if we check that, we'll see that it's only kept our presidential race stuff there. You were confident that our times counted rows were in fact all of the types of votes of the other ones summed together. So we can just filter to that one in our registered voters in order to get our turnout rate. So we could say filter, it was counter type. And we'll say percent in percent registered voters, comma, times counted. And if we go over here, we'll see that it's just registered voters or times counted over and over again. Pretty comfortable with that filter working. And then we don't really want the like leg column and stuff anymore. So we'll select just precinct and C flag and counter type and sum of count. So here's what we're looking at. We have our precinct. We know whether or not it's in Seattle. We have our column that tells us the registered voters and the times counted that we're going to deal with in a minute, and our sum of count. Are we cool so far at this stage about what's going on and where we're at? Okay. Now, since we have talked about how we had that column that's too long, we're now going to pivot wider that column using the pivot wider function. And we're going to take the names from our counter type column and the values from our sum of count column. So before I run it, I'm going to show y'all what I'm saying. So here we have a column that I'm saying is too long, which is that the column has more than one type of information in it. And so we want to take the names from our counter type column and our pivot wider call, taking the names here. So this is going to become its own column, and the name of that column will be this value. And then this is going to become its own column, and the name of that column is going to be this value. And then the values within that column are going to be this information. So like our first row of registered voters in the new column is going to say 519. Let's see. So what we've done is we've taken that column and we've made our data set wider. With registered voters is now a column times count is now a column. And our first row is 519, for example. So we're cool with how that pivot happened. I'm so glad they made pivot. R used to have this thing called spread and gather, and it was this whole big mess. Things have gotten easier since pivot came out. But now we can just do math across our registered voters and times counted columns. We could say mutate turnout equals times counted. I put this in backticks because I'm really worried about it not reading the space correctly, but it might. You could, but it used to be the case that R did not like people doing that. And so I just still use backticks because it makes me stressed. But now we have this new cool column called turnout. We should actually probably give this its own. We could assign it to turnout rates. And then see head turnout rates 10 or tail. But it looks like folks be out here voting in Seattle. And that's it for part 1. We did it. So I'm going to turn off the recording and then answer some questions. If I can figure out how to do it.